All right, finding side lengths using trig ratios. Now that you know what those trig ratios are, which remember is so, ka, toa, and that's sine, theta, or any angle. And we're going to talk about changing out theta and putting in an angle today, equals opposite over hypotenuse, cosine, which is adjacent divided by hypotenuse, and tangent theta equals opposite over adjacent. Now that you have those relationships and those ratios, we're actually going to go ahead and solve some side lengths on triangles, and it's going to be, once you get the rhythm down and the understanding of the ratios, it'll make a lot of sense for you. So instead of theta today, and we're going to have hypotenuse opposite, because remember the side opposite theta, and then adjacent. Okay, we're going to go ahead and delete theta. Theta's gone. And we're going to have a measurement like 20 degrees. And then opposite is going to be x, and adjacent is going to be some number. And we can actually solve for this x value, even though we do not have the hypotenuse. So that's going to be the cool part about trigonometry, is the fact that we only need one side length and an angle, and we can find any other side length. Okay, so with a lot of missing information, trigonometry makes math so much easier. And you will be using this idea or this concept next year in physics a lot when you're trying to figure out different forces from different side lengths. All right, so what we're going to start on today is our lesson on trig ratios, and then we're going to practice solving the missing side lengths using trig ratios. So that's what we're going to work on today. Okay, so for the first example, you will need a calculator today. So if you have a calculator at home, find it. A scientific one would be much better than using your cell phone. But if you do not have a cell phone, or if you do not have your calculator, using a cell phone is okay. When you use your cell phone, you might have to turn it sideways, or all the cell phones are different, so you might have to find where there's extra keys. So turn it sideways, see if you can find sine, cosine, or tangent on your phone right now. All right. Now remember remember the last lesson we talked about having this relationship written out on the top of your paper. Do that now on your notebook, because remember, it's going to follow us for everything that we're doing. So ka, toa. And it's a quick way for us to go ahead and remember what the relationships are without having to write them down every single time. All right, so when we were finding the side lengths using trigonometry, the very first step is you're going to go ahead and identify your opposite, adjacent, and hypotenuse. Drag and drop those onto your triangle. If you're writing this out on your notebook paper, awesome. Recreate the triangle, and then we're going to go ahead and label it. Now, you'll notice something. We are no longer using theta, but 28 represents theta. It's the angle that we are setting everything to. So what we're going to do is the number across from 28 is going to be our opposite. The number across from the right triangle is our hypotenuse. So in this case, we only are given hypotenuse and opposite. So in this case, we're going to go ahead and take a look at hypotenuse. So it's not going to be tangent. It has to be cosine or sine, and then opposite. So that leaves us with sine. So when we set this relationship up like we were in the last lesson, we're going to use sine instead of theta. It's going to be sine 28 degrees equals, and then our relationship, or our ratio. In this case, opposite is in the numerator, 19 is in the denominator, and we need to solve for x. Now, this is where the part that you do know how to do. So if something's being divided by 19, okay, we can go ahead and multiply both sides by 19. Now, sine 28 is an actual number. If you didn't have a calculator, I would give you all trigonometry ratio tables, and it would tell you what ratio this is. Your calculator already has the ratio stored in its system, so when you type in sine 28, that number comes up. So your calculator has that memorized. You, by chance, will never be able to memorize all of those ratios. Well, I shouldn't say never. There are people out there that memorize things like that. Okay, but let me just show you real quick what I'm talking about. So what I'm on a calculator, this calculator, if you use the one on the computer, I don't know if it's going to be the same one, okay, but it has a button for trigonometry up here that you're going to be able to use. And then for this one, you have to type in 28 before you press sign. Okay, so I would like you practicing your calculator. See if you can go ahead and figure out how to get sine 28. So we have 28 times sine, not sin. Okay, and notice how it comes up with that very long number. All right, I'm going to go ahead and multiply that because I have to multiply it by 19, and that's going to give me 8.919959. We're going to be here all day if you write it out like that. Okay, so we're just going to round to the nearest tenth. So x is going to equal 8.9. All right, so that's going to give us our side length, 8.9. And that's approximately right because we want our hypotenuse to be the largest side. And we can also find this length too later on, but let's not get ahead of ourselves. It's just asking for this side. So let's go ahead and stop there. If you can't get 8.9, keep trying until you get 8.9. It might be that you typed in sine first, because if I press sine, let's clear everything out. And everything, please. Okay, if I press sine and then 28 and then multiply it by 19, notice how I get a completely different answer. Okay, that's because it's saying sine 0, which neither of these are right. Okay, that's because sine 0 is just 1. Oh, it's up here. Sine 0 is 0, and then we multiply 28 times 19. So you need to practice until you get 8.9. Just to make sure that you're calculating everything correctly. All right, so let's go ahead and take a look at some more example problems. Now, let's go ahead and first step, so toa. You might want to rewrite this every single time just so you get that down. That way you memorize the trig relationships. All right, let's go ahead and take a look at identifying the different side lengths. So I'm going to first start with the hypotenuse, opposite the right angle. If we have 41, the opposite of that is x, and then the adjacent is here, which is 31, or 32, sorry. All right, so we don't have a hypotenuse. So in this case, it's not going to be sine, it's not going to be cosine. It's actually going to end up being a tangent relationship because we have opposite and adjacent. So when I'm setting this up, we're going to end up having tangent 41, which is opposite in the numerator, adjacent in the denominator. So the opposite is x divided by 32, and we're going to end up, we need to go ahead and solve for x. Because x is in the numerator, life is so much easier. Because if it's x divided by 32, we're going to go ahead and the inverse multiplication of division is going to go ahead and we're going to multiply both sides by 32. This needs to move over just a little bit. You too. All right. 32 times tangent 41. Just remember, tangent 41 is a number, and we can figure that out. On this side, this all becomes 1, and we're left with x equals, well, let's go ahead and figure that out. All right, so I'm going to clear out everything over here. Okay, and so remember, I need to type in what's inside this angle measure first. So 41 tangent. Okay, so that gave me that value. And then, wait, it says 28 times tangent 41. I do not want that. Back up. Clear everything out. See how it's 0? That's what we want. Okay, 41 tangent. There we go. Okay, so you should end up with 0.8 869. The next thing that you're going to do is you're going to go ahead and press multiply. And we're multiplying by that 32 that's in the outside, that coefficient there. And you should end up with 27.8. Okay, so we're going to end up with 27.8. The number behind the 8 is a 1, so I'm going to keep it where it's at, equals x. All right, this is when I would love to ask you, do you have any questions or anything I can help you out with? But I can't because it's a video and I can't talk back to you and I can't hear your questions. So hopefully someone's in the room that can help you out. Otherwise, please go talk to Mr. Bull. He'll help you out in tutoring. All right, so that's for example 2. Okay, pause it, back up if you need it. Okay, now this one's going to be a little different, I think. Yes, this one's going to be set up a little bit different. First step, so ka toa. All right, and that's to help you memorize those ratios. Now let's go ahead and set it up by naming it. Here's our angle theta. Here is our hypotenuse because it's opposite the right angle, and this side is adjacent because it's right next to our angle. And if you want to, you can say, okay, that's opposite. If that's easy for you to label every single side, go for it. Okay, I don't care about opposite on this one. I just need adjacent and hypotenuse. So when I'm looking at this, it's not going to be sine. It's not going to be tangent. We're going to work on cosine this time. Cosine 21 degrees equals adjacent divided by hypotenuse. So adjacent goes in the numerator and then hypotenuse goes in the denominator. Okay, this one's actually not different at all. We're going to still multiply both sides by 26. That becomes 1. We're left with x equals 26 times cosine 21. We're going to go ahead and figure that out. I'm going to try something different this time. What if I try 26 in parentheses, cosine, nope, I need to type in 21 first, the way this calculator is working. And I'm going to delete all of that I have. No, I'm just going to stick with what I have. So, first thing we want to do is go ahead and calculate cosine 21. So it's going to be 21 times cosine. And then once we have that ratio, we're going to go ahead and multiply that by 26, set equal. We're going to end up with 24.27. Now that 7 is going to tell us that we need to round up because 5 and above give it a shove. So that's just going to end up giving us 24.3. And that's going to give us our x value. That x value is this adjacent side, 24.3. All right. Now I have to say that trigonometry is utilized in different aspects of real-world mathematics in a lot of different ways. When we're surveying, surveyors use trigonometry in a lot of different ways to find the distance between 2 points, because you can set up a right triangle and then find that missing length by only having one other measurement. So you don't need all the other pieces of information to be able to use Pythagorean theorem. That's the cool thing about trigonometry. All right. And there's many other uses in real life mathematics. A lot of physical applications or physics applications utilize trigonometry. All right, let's go ahead and take a look at number 4. For number 4, we are going to go ahead and start it off. So we have so ka toa. Now with SOHCAHTOA, first step, name all the sides. So here's our side adjacent. This is the hypotenuse, easiest one to identify, and then if that's the hypotenuse, that's the adjacent, this is the opposite. Okay, if you label that incorrectly, you will end up with the incorrect answer, so make sure you are able to label all of those sides. All right, next step, I don't need the hypotenuse, so I know it's not going to be sine or cosine. In this case, this problem is going to end up being tangent. because we're left with opposite and adjacent. Okay, so with this problem, we're going to go ahead and set up tangent 55 equals opposite, which is x divided by 8. Okay, next step, go ahead and multiply both sides by 8. We're just going to end up with 8 tangent 55. Go ahead and calculate that on your own, and you can check your answer with me because I'd like you to calculate all of these by yourself before me so that you can make sure that you understand how to use the calculator before quiz day. And I'm noticing I'm going to have to clear out the calculator every time. Why aren't you clearing completely? All right, now I've got it completely cleared. I do not like this calculator I'm feeling, so we're going to start off with 55 tangent, okay, times 8, and that's going to set equal to 11.4. Woohoo! And that equals the x value, our missing side. So 11.4. Now that we have two sides, we can find the third by using Pythagorean theorem, or we can plug it in and find it using hypotenuse. We either have adjacent or opposite, so we can use tangent or cosine. Your choice. But this problem doesn't require us to go ahead and find two different side lengths. It's just asking us for one, so we can stop right there. Okay. Let's go ahead and take a look at number 5. So for number 5, let's go ahead and start it off with sine. So ka toa. And we're going to go ahead and identify those sides. Okay, so I'm going to pause the video, set it up. You tell me what you show me what you got by checking what I have compared to yours. Alright, so I ended up with sine 33 equals 15 divided by x, because we're ending up with opposite divided by hypotenuse. Okay, now this one does look a little different because we're not dividing by a number, so don't get into the routine of always dividing by that number. What we have now is we're dividing by x. So we're going to have an extra step here, but it's not the most difficult in the world. Okay, so go ahead and take a look. If it's being divided by x, we need to go ahead and multiply both sides by x. That becomes 1. I'm left with x times sine 33 equals 15. Now, we're going to treat sine 33 just like it is a number, because remember, it is just a number. So if I have something like 5, or say x times 5, crazy 5, equals 10, what would you do in order to solve for that equation? And I hope you're thinking in your head, well, because it's being multiplied, I'm going to divide both sides by 5, and that would just give me 2. And that's exactly what I'm hoping you're thinking here too, because sine 33 is just a number, so we're going to go ahead and divide both sides by sine 33. This becomes 1. I'm left with x equals 15 divided by sine 33. All right, let's go ahead and try this in our crazy calculator. So first, make sure everything's cleared out. That's what I've figured out. Okay, and on this one, we are going to go ahead and we want to calculate 15 divided by sine 33. So I'm going to try something different here. So I'm going to take 15 divided by, in parentheses, 33 sine, close parentheses, close another set of parentheses maybe, equals, there we go. So you have to press the equals button, otherwise you only ended up calculating sine 33. So the correct answer, or the final answer on this, is going to give you 27.5. Awesome! X equals 27.5. Okay, so double check that you can calculate that, because on quiz day, nobody's going to show you how to do it. You need to kind of practice that until you end up with 27.5. Okay, I would love to ask the question, do you have any questions? but like I said earlier, can't hear you. So I hope if someone's in the classroom, they can answer any and all questions for you. Or you can go see Mr. Bull. He is definitely going to help you out if you need it. All right, let's go ahead, and what I'd like you to do now is you are going to set up and solve number 6, number 7, try number 8, and number 9. Okay, and I'll come back. Make sure you draw a diagram on both of these, set up the ratios, and solve it out. Okay, I'm going to come back with the solutions. Here we go. Hope you pause. All right, I hope at this point you're checking your own work, so that way you can go ahead and pause, fast forward, stop the video if you need to just for a minute to try to see what the math was, but you're just checking your answers at this point. So for the first problem, it's x equals 49.2. For the 7th example, example 7, it should be 4.8. For example 8, you should have received 4.5 feet. And I'm going to explain these because if we're talking about Jake leaned a 12-foot ladder, so if you're leaning a ladder against a house, that's going to be this long side right here. And then this would be the house wall. This is not going to be to scale, but this would be the house. And then the angle formed by the ladder and the ground. So from the ladder right here all the way to the ground is going to be 68 degrees, so that angle is going to be represented here. How far from the base of the house did he place the ladder? That would be this side right here. So we're looking for adjacent and hypotenuse, and adjacent and hypotenuse has everything to do with cosine, ka. So cosine 68 equals adjacent divided by hypotenuse, and that's going to give us 4.5 feet. All right, so for example 9, a ramp is used to load suitcases on an airplane if the cargo door is 7 feet, from the ground, and the angle formed by the end of the ramp and the ground is 25 degrees. How long is the ramp? So that's this length right here. That's what we're looking for. Okay, now if we're looking at ramp, this would be our 90-degree angle. Opposite the 90-degree angle is our hypotenuse. Opposite the angle that we're in respect to is going to be opposite, which is 7. So hypotenuse and opposite would give us which is sine 25 equals 7 over x, and then we just have to multiply both sides of x to get x out of the denominator. Then, because x is being multiplied by sine, divide both sides by sine. And then that would give us 16.6 feet. All right, so there are some more practice problems that you're going to work on Khan Academy for this until you get the rhythm down and you understand the relationships, because you will utilize this a lot next year in physics. So I need to make sure that you guys have a solid understanding of trig before you guys move on. And in other classes in the future too. So I hope you guys are doing well, and I'll see you at some point or in the next video. Bye!